A very good morning, students. Today we are going to discuss about the overall transfer function, in which we are going to discuss about open loop and closed loop transfer function. So as you are aware with this block diagram, already we discussed about the various terms used, symbols, and the transfer functions used in overall transfer function block diagram. So as you know, R is a set point, B is a measured variable, epsilon is error, Gc is a transfer function of controller, G1 is transfer function of final control element, G2 is transfer function of process, U is a load variable, capital M is manipulated variable, capital C is control variable, and H is nothing but a measured variable, transfer function of measured variable. Today we are going to discuss about what is the open loop and closed loop transfer function. The series of blocks between a comparator and a control variable means GC, G1 and G2 is called as a forward path. The blocks between the control variable and comparator is called as a feedback path. The product G into H, which is a product of all the transfer function, means G is GC, G1 and G2. H is a product of all H. So GC, G1, G2. H is nothing but called as a open loop transfer function. We call this G into H is open loop transfer function because it relates the measured variable B and to the set point R if the feedback loop is disconnected at the comparator. Means if the loop is connected at this comparator, then it is called as a open loop transfer function. And when this loop is closed, when B is connected to the comparator, then it is called as a closed loop transfer function. The block diagram has showed control system. Then the next step is to determine the transfer function C by R or C by U. We shall refer this transfer function as an overall transfer function because they are applied to the entire system. These overall transfer functions are used to obtain information about the control system. What is the overall transfer function? Overall transfer function is a Laplace transform of the control variable C of S upon the Laplace transform of the set point R of S. Means C by R is overall transfer function if we put U is equal to 0. That is a servo problem. You know. Overall transfer function also can be written as Laplace transform of control variable C of S upon Laplace transform of load variable U of S, that is C by U. It is possible when a set point R is equal to 0 and it represents solution of regulator problem. So you should understand what is a servo and regulator problem that earlier we discussed. Then you will understand this overall transfer function definition. Now we will discuss this overall transfer function for set point change. Set point change means servo problem. In this, now we are going to reduce the block diagram and we are going to find out the final overall transfer function. So overall transfer function for set point change is obtained by putting U is equal to 0. See, we put U is equal to 0 in the previous block diagram. Then it represents the solution of servo problem. In this case, block diagram is reduced and shown in following manner. So we'll write this GC, G1 and G2 is nothing but G, only G. Whatever the transfer function between this feedback path, you can write it as H. So now what is remaining? R, epsilon, B, G, which is a product of GC, G1, G2, C and H. So we have reduced the block diagram. Further, again we reduce the block diagram to this one. We written G is equal to GC, G1, G2. So we can write this C by R is nothing but equal to G upon 1 plus GH. This is called as a overall transfer function for servo problem. Now how this comes? We'll see one by one. We'll solve the different equations and you will come to know. So this is nothing but C is equal to G into epsilon. You will ask from where it comes. C is equal to G into epsilon. What is epsilon? Epsilon is equal to R minus B, because this is plus, this is minus. So epsilon is equal to R minus B. Then B is what? H into C. B is equal to H into C. So we have written these three equations. We'll combine these all three equations together. Okay. So C is equal to G into R minus B, then this equation, and finally you will get C by R, that is C of S by R of S is equal to G upon 1 plus GH. So this is overall transfer function relating C to R, which is a solution of servo problem and may be shown by the equivalent block diagram. Where it is? This one. C by R is equal to G upon 1 plus GH. Next we will discuss about the overall transfer function for change in load variable, that is a regulator problem. In regulator problem, what we do? We put R is equal to 0. See here, we put R is equal to 0 and U will come into the picture. Load variable will come into the picture. So again, if we solve this, you will get this overall transfer function for the regulator problem. C, U and the transfer function will be G2 upon 1 plus GH. How it comes? Again, we'll reduce the block diagram. We'll write the different equations and we'll correlate. So first equation, what will be the C? C will be G2 into U plus M. Have you understood? C is equal to G2 into U plus M. You just understand this. Then what is M? M is equal to G1 GC into epsilon. What is epsilon? Is equal to R minus B. But R is equal to 0, so epsilon is equal to minus B. What is B? B is equal to H into C. You will find all these equations here. See here. These four equations you can write like this. Then again combine all the equations. Finally you will get C by U. That is a C of S upon epsilon U of S is equal to G2 upon 1 plus GH. So this will be nothing but the overall block diagram. C by U is equal to G2 upon 1 plus GH. So now what is the conclusion from this is, in both cases G is equal to GC, G1 and G2. Means that overall transfer function for set point change and for load change having a same denominator. So denominator for both equation for C by R and C by U, you observe it is a 1 plus G into H. Now we will discuss some problems related to the reduction of the block diagram and finding the overall transfer function. So this is of example 7.1. Determine the transfer function C by R, C by U1 and C by U2 for the given control system. So now we will write this C by R and C by U. So first of all we will write C by R. C by R is equal to what? So you have to write the product of all the transfer function between C and R. So product of all the transfer function is GC, G1, G2 and G3 upon 1 plus GH, 1 plus product of all the transfer function GC, G1, G2, G3, H3, H2, H1. You will understand now. C by U1, what will be C by U1? C and U. these are the two terms. Take a transfer function between only these two variables. So there are only two blocks, G2 and G3. So C by U1 is G2 G3 upon 1 plus all product of transfer function. You will understand. C by U2. What is C by U2? Take a transfer function between C and U2. It is only G3. So C by U2 is G3 upon 1 plus GC G1 G2 G3 H3 H2 H1. So what you can write? You can write from the first equation C is equal to GC G1 G2 G3 upon 1 plus G into H. G is product of all G, H is a product of all H into R. What will be the C by U1? It will be G2 G3 upon 1 plus GH into U1. What you can do is, if they have asked you to combine both effect together, if R and U occur simultaneously, then you can just add the two equations. C is equal to this product into R plus this product into U1. Sometimes the problem are asked based upon the inner loop. So this dotted line is shows as inner loop. You have to determine the transfer function C by R for the following system. So if this dotted line is that, it means it is a inner loop and you have to solve that inner loop first. Then you can solve the remaining problem. So see how it is to be solved. So see here, GC2 G1 upon 1 plus GC2 G1 into H2, that is a G4. We are writing this dotted line, the overall transfer function like this. Have you understood? Then you can combine this G2 G3 together. That will be G5. So this is G5, this is G4. GC1 is as it is. This feedback path H1 and H2 we can combine H1 and H2, H3. Then you can directly solve this equation without writing the equations. What you can write? You can write C, you can write R is equal to what? It is a GC1, G4, G5 upon 1 plus GC1, G4, G5, H1, H3. Finish. You got the answer. This is the answer. C by R is equal to this one. Most of the time such problems are asked in examination. Problem 7.3. Determine the transfer function y of s upon x of s. So how to solve this? This is little bit complicated, but once you understand, you can solve any problem directly. So in these problems you have to put some unknowns. So I have put A, B, C and D. You have to understand where to put these unknown variables. See how we can solve this problem is. What is A? A is equal to GA into X. What is B? It is nothing but A minus Y. You will ask why? Because see here, A is plus, Y is minus. What is the C? C is equal to B into GB. What is the D? D is equal to C plus X. What is Y? Is equal to GC into D. So you will find all these equations here. Y into Y is equal to GC into D. So again combine all the equations where you have to find out Y. So combine all these equations together. You will get the equation for Y by X is equal to GC bracket 1 plus GB GA upon 1 plus GC into GB. So this is how you can solve many problems related to the overall block diagram, and it is related to how to reduce the block diagram. So we'll discuss the last problem and we'll stop it here. Problem 7.6. Determine the overall transfer function C by R. So here again you can see there are inner loop. This is one loop and this is another loop. You have to find out C upon R. Again you have to put some unknown constant if it is not given, and then you can start solving. Now tell me, what is the C? C will be G4 into E. Is it right? Yes. What is E? E is equal to Z minus B. Now you understand. What is Z? Is equal to G3 into Y. What is Y? X plus C. What is X? Is equal to A into G2. Into you can write GA. What is A? A you can write G1 into R. And what is B? B you can write H into R. So you can write all these equations and again you can combine to find out the value of C. You will get this equation. What you will get? C by R or is equal to C of S by R of S is equal to G1, G2, G3, G4 minus G4 into H upon 1 minus G3, G4. So this will be your final block diagram. C of S, R of S, and this will be your transfer function. So I will suggest you to solve these 7.1, 7.2, 7.3. It is very easy to find out. You will find it is very interesting. Solve these problems. Solve the problems from the university examination related to this, and you will find this will be a very interesting topics. So thus we have finished chapter 7. Tomorrow we will discuss the chapter 8 about the transient response of control system. Now only the 4 chapters are remaining from the process dynamics and control, which are very important, that will finish within the next 4 video lectures.